moving up the stack to the transport layer, now we're talking about the communication that's occurring from one host to another host across a network, no matter how large the network is. If the network is a crossover cable between two PCs, that's the size of the network, and that's as far as each host is going to communicate. They'll be setting up a circuit from one host to the other across that network. Or the two hosts can be all the way across the world. We could be talking about a computer here at the United States communicating with some web server that's in Tokyo. In either case, we're still creating a session from one host to another host. Now, you talk about the protocols that are actually occurring here from a TCP/IP perspective. The TCP protocol is a layer 4 protocol. It creates the circuit from the endpoint to another endpoint across a data network, again, regardless of the size of the data network. So the transport layer, another protocol, the transport layer, would be the UDP protocol. So there's a couple of key things here to understand at the transport layer. The transport layer has the ability of creating connectionless or connection-oriented circuits. Now, a connection-less circuit means that we're using best effort technology to send the data back and forth. We still have identified the two endpoints in question, but we're not necessarily doing anything such as sequencing or error correction at this layer. Doesn't mean we couldn't do it at a higher layer, but it doesn't mean it means that at this layer, the transport layer, we're not doing any form of correction or any true establishment of session between the two devices. The other option, being, say, TCP, we can actually establish a circuit between the two, create a session, and create an actual connection. And then during that connection, we have the option, and well, TCP builds it into the option, but we have the capability here to be error checking. So we can identify each of the packets, and if it changes or something goes wrong with the packet, we can request retransmission, and we can be both connection-oriented and reliable. So the option here is that with TCP, it can create a connection-oriented session that is reliable in nature, meaning we can retransmit if there's a failure in the circuit, and at the same time we've established a session between the two devices that's both created, we've agreed that we're going to talk, and then data is transmitted and then torn down when we're done. We'll get more into how TCP operates here at Layer 4 as we move further in the course. All right, so Session 5, 6, and 7. Session 5 is a session layer. We manage the session that's going to be occurring between the two devices. Really what we're doing is we're identifying ports and communication facilities that are communicating from a device to device, again, regardless of the size of the network. The presentation field is how the data is actually going to be presented to the application in question. For instance, if we're talking about a terminal application like Telnet or Secure Shell, the presentation layer is typically going to be ASCII or IPSIDEC or some form of character emulation. So in the case of Telnet, we have ASCII-based terminals, so we're going to have an ASCII-based presentation layer, and that's how it's expecting the data. If it was Secure Shell, we'd take the ASCII data and we'd use the presentation layer to take that ASCII data and then encrypt it for us before sending it across the network, because we can't ensure the integrity of the data as it's traversing our network and want to make sure nobody's looking at our data. But other kind of presentation layer examples would be things like GIF or JPEG or MP3. These are all encoding mechanisms to identify the data and how it's going to be handed to the application. Now, the application itself is any form of application that is providing host-to-host communication. The application layer, again, is identifying things that are inter-host communication protocols, but not necessarily application-based, user-based applications that are designed for creating documents or manipulating photos or so on. A good example of this is, say, Microsoft Word. Microsoft Word is designed to create documents, but not necessarily designed for inter-host communication. There's a subset to that example, though. If you go to File, Save, and save the document and use that little pop-up window to navigate over to your server somewhere so you can save your document on your server, that little applet is actually a host-based application, a network-based application that is going to communicate from one host to another host. So that portion of the Microsoft Office suite, which is the same no matter which Microsoft Office application you open up, that allows you to surf the network as you're saving your file or opening a file across the network. That little portion of the application could be considered an OSI reference model based application, whereas the whole application itself wouldn't be.